Okay, so now let's look at the results. All right, so this is where we were before. I'm going to click on the results button. This is going to start another program called Hyperview. You can execute that separately, but whatever. So here it comes. It's loading. This is built into HyperMesh as well. You can actually look at the results in HyperMesh, but this is kind of a little bit of a nicer program for doing it. So here you can see it loaded up the data. There, when it solves an OptiStruct, it makes this H3D file. That's the results file. You're going to use that both for the load and the results. So we're going to hit apply, and there it is. Oh, actually, it's already there, so that's what it's complaining about here. So we're going to just leave it as is. And so there's our model. Doesn't look like much because we're not telling it yet what to display, all right? So let's do the deformed plot and then look at the bending stresses, okay? So I usually use these buttons down here on the bottom mostly. I think it actually by default has the deflection in it. So if I drag this little slider bar, it's going to do the deflection, or I could hit this little play window and it's animating it. I don't know why it's always set really fast, so this bottom slider allows you to slow it down. And so there you go. That's kind of like, you know, I don't know. There it is. Very nice. Okay. Let's plot the stresses, okay? So to plot like different things on the mesh, you pick this icon here with the little, looks like a dithered mesh. So I'm going to click on that. And this now is going to ask you, okay, what do you want to plot? So you can plot the displacement, but we want to plot stresses. So I'm going to pick element stresses 2 and 3D. And you can plot the von Mises, but we want to do the bending stress. So that's the normal stress in the Z direction, right? So I'm going to scroll down and you can do max shear, the principles in plane, all that sort of stuff. But I'm going to pick the ZZ stress. So that is the normal stress in the Z direction. And like you can resolve it in different systems. Like if you resolve it in the elemental system, it's going to look really weird because elemental system is defined in an unusual manner. But we would probably, usually I use the global system. And so now when I talk about normal stress in the Z direction, I mean projected into the global XYZ. So now if I do apply, well, now I get something that looks a lot more reasonable. I can see I get max stresses here at the root because the bending moment is the max. And then I also get more at these corners like we saw when we did the hand calculation, right? So this looks pretty reasonable. We can animate it and do that sort of stuff. That's kind of nice. Another thing we can do is zoom in here, which is this is pretty obvious. So a lot of times in this class, we're going to want to know values at actual nodes or elements. So I can change the display. So what I'm going to do here is try to get the displayed values of the sigma ZZ stress, the normal stress in the Z direction, at a couple elements. So the way to do that is through this little spreadsheet looking icon here. That is what they call query, I think. Query, there it is. So click on that. And now you can pick like elements or nodes. So I'm going to pick elements. Wait, don't do that. I'm just going to manually pick them. So I'm going to pick like that element. So here it gives me the Z stress for that one. And then I can pick that element. And I can pick like maybe that element and that element, right? And that gives me the actual values for the stresses. You can export this into a spreadsheet. If you want to, we can also plot out some displacements. So I'm going to pick the nodes. And then I'm going to pick that node, that node, and that node, and that node, and that'll write out the coordinates of those nodes. I believe I can also tell it what to. Can I? Oh no! If I wanted it to display the displacement, I would have to go back and shade the displacement, and that would give me the displacement. Okay. But anyway. So that's kind of good. So I think actually let's do elements again. I thought it would have put them all there, but it once I toggle from elements to nodes, it kind of goes away. But come on, elements. So I'm going to pick those elements again. This one, 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 this Okay, so you can do that. If you want to make a screen snapshot, you can actually like just do the regular Windows screen snapshot. But a lot of times you want to have a white background. So if you pick this icon here, I think it's this icon, capture graphics window. Sometimes that's not there. So if you, how do we get that? Right click on here? No. Tools, preferences. Oh, no, I'm not going to remember. I think it's view, right? View, toolbars. No. Oh, tab. No. Where is it? Oh, I never know. Whatever. Okay, I think it is here by default. Anyway, so you pick that one, and it will ask you to, save it as some type of graphic file, JPEG or something like that. Okay, and you can get a nice image. You can also export out a video if you're animating it, right? You can go into here and like export as a movie, and it'll do that. Okay, that's pretty much it. All right, that's how you do it. And so keep track of those big steps: define the materials, the property cards, make the mesh, boundary conditions, and then load step. And then you shouldn't have too much problem solving these things. Like I said, to start with, we're just going to be using these simple shell element meshes. If we're putting forces at the end, use the RBE3 element, okay? And you should be good from there, okay? All right, good luck.